Hello guys, Ashish here. In this video, I would like to share one of the problems that I solved from the course that I'm taking on data structures and algorithms. It's on Udemy and I will share the link to it in description. This problem uses concept of multi-pointers to find optimum solution. Just a disclaimer before the video, I am just learning these things. If you feel that there is a better way to solve the problem, do share that in the comment section below. One last thing before going to the video, thank you all for watching. We are about to hit 1,000 subscribers. Thank you for all the support. Now let's jump into the video. Let's read the problem statement that is given here. Write a function called average pair given a sorted array of integers that and a target average. Determine the pair of values in the array where average of the pair equals the target average. So we have a target average and there is an array given, and we have also given that the time complexity should be O of n and the space complexity should be O of 1 or constant space complexity, and we have given some sample inputs here. So you can see that when the input array is 1 2 3 and the target average is 2.5, we want to return a boolean of true. So it's 3 plus 2, 5 by 2, it's 2.5. So that is why it should be true. Similarly, in the second, you can see that the target is 8 and we have 10 plus 6, 16 by 2, 8. In the other cases, there is no such average, so we need to return false. So first let's try out the brute force method, that is using double loops or nested loops to run to get the solution. So this is not the optimum way, as the time complexity is O of n square, but we want O of n. But first let's begin by solving the problem. The array takes two parameters as the input. First is the array itself, and the second parameter is the target or the average that is given into the function. And for the nested loops, we'll create a first we'll create a for loop, and inside that we'll create another for loop. But before that, let's look into the logic. So there is the target average that is given. So it is given by sum of two numbers divided by 2. So if a and b are two numbers, then a plus b by 2, which means that average times 2 is a plus b, right? So we need to find the two numbers a and b. So we'll create a variable called t, and we'll multiply the target value by 2, so that we just need to find the a and b values from the array. In this double loop, we'll assume that the first element, each element of the array is the first element of the pair, and to get that we'll subtract t minus the current element in the array. And now let's start the second loop. For that, we'll create a for loop and we'll initialize with j of 0, and just like the previous loop, we want the loop to continue till j is less than array of length, and we'll increment j by 1 on every iteration. And what we'll do is we'll check if the a, which is the array of I, is equal to array of j, which is b. So if that is true, we'll return true, and if that is not the case, we'll just return false. We also check one more thing. We'll see if the array is empty, and if the array is empty, then we'll return false there itself. Now if we check the solution, this is supposed to work, but the time complexity in this is O of n square and not O of n. So that is why we need to change the solution, and we need to write a better solution for this particular problem. To do that, we'll be using multi-pointer approach. So for that, we'll create two pointers that will move in the loop from left to right and from right to left respectively. And the logic is that for in the case of first example, say when the array is 1 to 3, the left pointer will start at 0 and the right pointer will start at the last element, and it will loop till left is less than right. And what will happen is we'll create a variable called sum, and we'll set the sum as the sum of, say, first element and the last element, which is the pointer at left and right respectively. So in the case of 1 2 3, 1 is 0 is the left index for the first iteration, and 2 is the first uh, index for the first iteration. Then we'll check if the sum is equal to t is the average times 2, and if that is true, we'll return true. And we'll check if the sum is greater than t. If that is the case, we'll move the right pointer down to 1. And if the opposite is the case, that is, if t is greater than the sum, then we'll move the pointer from left to right in one index. When we run the program here, you can see that the solution is incorrect. So let's add some logs in the code to see what is happening exactly. So in the log, we'll log the sum and the t, which I use for checking, and then we'll log the left and right as well. So you can clearly see what is happening in each iteration. So now you can see that in the iteration, the sum variable is not a number, and that is causing the issue here. So the issue was because the right variable was set to array.length, but it was supposed to be array.length -1, and we'll set the sum to 0 at the end of the loop. So now if we check the solution, you can see that it's coming out correctly. Let me just explain the iteration once more so that you can understand more clearly. So at the beginning of the loop, we have set t as the target times 2. So in the case of second example, where the average pair is a big array and the target is 8, you can see that we have set t as 8 times 2, which is 16, and we have set left and right pointers that started first and the last index. And then for each iteration, we'll check if 16 equal to the first or the first and last element's sum, which is 19 plus 1 20. 20 is greater than 16, so we'll reduce the right pointer to 1. So in the next iteration, we'll take the second last element from the right, and we'll do that until we find that 16 as the sum by the left and the right array, and we'll do it until left is greater than right. So once the middle point is crossed, the iteration stops. I hope you found this video useful. If you did, comment your thoughts below. Thank you for watching, and see you guys in the next one.